Hello, everybody. Welcome to 2.6, nonlinear inequalities. This isn't necessarily a notes section, but more so like we just need to do problems together and you see problems and you do problems. So examples, we got x squared plus 5x plus 6 is less than 20. So there's a few strategies we need to do when applying this. Let's make one side 0. That's probably the best strategy in this case. It would be minus. Then we factor plus 7 x minus 2. And the values that make it 0 are 7 or negative 7 and 2. Now, in solving inequalities, we're going to make a chart with our zeros. Okay, negative 7 and 2. Usually what happens whenever we have a 0 is a lot of times it changes from positive and negative to positive, right? So in this case, since we've got inequality that's less than 0, we're looking for when is it negative, okay? So if we put a value greater than 2, what happens to these terms? It's going to be plus times a plus, which is going to be positive, right? So greater than 2 is not going to work, right? Positive times positive is going to be positive, and any positive number is not going to be less than 0. Between negative 7 and 2, if you pick any number, say 0, you're going to get, I don't even care what the exact number is, I just want to know it's going to be positive or negative. You get a positive times a negative, which is going to be negative. So yes, that's going to work. And then less than negative 7, you're going to get a negative times a negative, which is going to be a positive. That won't work. So what are the values that work for this? That will be your answer. In interval notation, I'd expect negative 7 to 2. And yes, I got parentheses because why? Because it's not or equal to. Next, we got the quantity x minus 4 squared is greater than 4. FOIL that and do the same thing we did before. FOIL, we get that. Subtract 4, subtract 4. You get x squared minus 8x plus 12 is greater than 0. Factor again, x minus 6, x minus 2. Number line it up. 2, 6. Greater than 6, we get a plus times a plus. So yes, that would work. Because that's greater than 0. Between 2 and 6, it's going to get us a negative times a positive, which won't work. And then less than 2, you're going to get a negative times a negative. That's going to be positive. That's going to work. So what's your solution? Your solution I'm going to put up top here is negative infinity to 2 and 6 to infinity. For this one down here, we can't back this one, sadly. Wait. Nah, we can't. So how are we going to solve this? By using our rational zeros test. So list all the factors. Plus or minus 45. Plus or minus 15. Plus or minus 3. Plus or minus 1 over. Plus or minus 2. Plus or minus 1. I forgot about plus or minus 9. Plus or minus 5. And that should be it. And when you plug them into your function, you get only 2 zeros. And those 2 zeros are negative 3 and 5 halves. You might be thinking, and rightfully so, you should be like, hey, there should be 3 zeros. Well, let's do a little test here and see why we only have 2 zeros when we probably should have 3. My guess is we probably have multiplicity somewhere. Greater than 5, over 2. So pick a number greater than 5 over 2 and see if you get a positive or negative. Let's say we got 3. Does it work? Is it greater than or equal to 0? It sure does. Boom. Good. So we know that part of our solution is going to be this. 5 over 2 comma infinity. Now in between, no, does not work. Less than negative 3, no, does not work. Negative 4, whatever. If I put 0 in, 0 is probably the easiest to plug in usually. If I put 0 in, I'll get negative 45. Why? That goes to 0, that goes to 0, that goes to 0. Minus 45. Negative 45 is not greater than 0, folks. And then anything less than negative 3 doesn't work. So what does the snapshot tell us where the multiplicity is? It's at negative 3, right here. Multiplicity at negative 3. Why? Because it's negative all around it, and we know this is our 0. So I probably did a graph where it hit negative 3 right here and just went back down. Pretty neat, huh? I think so. So this is not our full answer right here. It's not just this, okay? We need to include negative 3 in our answer because negative 3 is going to make your inequality equal to 0, which it is in fact greater than or equal to 0, right? So 3, boom. Negative 3, just put a bracket around negative 3, and you'll be set. Next, we have surprises. So, you may look at this inequality on the left and be like, oh no, I can't figure out what the zeros are. Well, that's okay, because why? There are no zeros for this. If you were to use a quadratic formula right now, you would get imaginary numbers. So what does that mean for us? Well, I know that my graph is either going to do one of two things. It's going to be facing up, somewhere over here. It's going to be facing down here. If we don't have a 0, it's going to do one of these things. Okay. Now, why do I know it's going to be this or this? You guys remember, that's positive and that's even, right? And if you remember our end behavior, that means it's going to be positive the whole time. And plus, if you don't believe me and if you can't think in this way, if you just pick a couple values for x, they're all going to be greater than 0. What's my point? If all the values are going to be greater than 0, you grasp one of these two, then your solution is negative infinity to infinity. Boom. Next, at 16, x squared minus 2x plus 1 is less than or equal to 0. Factoring in x minus 1 squared is less than or equal to 0, and you get 1 as a solution. Number line, 1. Anything less than 1 will not work. Aren't. Anything greater than 1 will not work. Aren't. Okay? But our solution is not no solution, right? Because it's or equal to 0. Okay? So if it's or equal to 0, that means we have just a solution of 1 it can be. So, this is the last part, and that's rational inequalities and solving them. So what I'm going to do with this one here, I'm going to move the 1 over. Then I'm going to get a common denominator. It's going to get me x plus 6 over 4x minus 3. And I'm just going to multiply the 1 by 4x minus 3 over 4x minus 3. X minus 4x will be negative 3x. 6 minus negative 3 will be positive 9. Now with our number line, its values will make either the numerator or denominator 0 when you have rational functions. What makes the numerator 0? That's 3. What makes the denominator 0? 4 over, or excuse me, 3 over 4 rather. If you don't believe me, just set the numerator equal to 0. You get 3. Set the denominator equal to 0. You get 3 over 4. Let's test. Pick a value less than 3 over 4. Less than 3 over 4, 0. Be easy on yourself. 0. That'll get us negative 3. Is negative 3 greater than 0? No. How I like to do this too is I just throw in, if I put 0, I want to get a positive over a negative, which is going to be negative. That's all greater than 0. No. Between 3 over 4 and 3, let's try 2. It's going to be a positive over a positive. Is that greater than 0? Sure. Greater than 3. That's going to give me a negative over a positive. That's a big no. Okay. So what is our solution? Now be careful here, okay? Because this value, unlike when it's, because we said greater than or equal to 0, one might think 3 over 4 is part of your solution, but it's not, because it makes the denominator 0. So that's going to make it undefined. If you need to make a little note and say undefined, do it. And make this say 0, do it. So what is our solution? So your solution is going to be parenthesis 3 over 4, comma, 3, bracket. 3 is included because it makes the numerator 0. And that's okay, because we want it to be 0. So, yeah. I'm going to move this over a little bit, though, so I have space for my other problem. And as promised, so let's move that 1 over x plus 5 over. We're going to get 1 over x minus 1 over x plus 5 is greater than 0. Common denominator. So common denominator is going to be a little trickier this time, because I need to multiply the top and bottom by x plus 5 for that fraction function, and x over x for this one. And that's going to get me 1 over, don't distribute yet, okay? If you distribute, you might end up doing more work for yourself later, okay? So leave it as x parentheses x plus 5 on your denominators. All right. And then like terms, so when we subtract, you're going to get 5 over x parentheses x plus 5 is greater than 0. Make our lovely number line of what makes the denominator 0. We got negative 5 and 0. And what is happening? Numerator? No value will make the numerator 0. So that's lucky for us. So we pick a number greater than 0, like 1. We'll get a positive over positive. Is that going to be greater than 0? Of course. Between negative 5 and 0, let's say negative 1. Is that going to got a positive over negative? Is that going to be greater than 0? No. And then we got less than negative 5, so that's going to get us a positive over a positive times a positive. Usually negative times a negative. I was just excited to say it's going to be positive. Negative times a negative, which negative times a negative is positive. Positive over positive is positive. Is that greater than 0? Of course. So what's your solution? Your solution is going to be negative infinity to negative 5 with parentheses because it's not or equal to, and plus negative 5 makes the denominator 0. 0 makes the denominator 0, so that's not going to be included in our solution, to infinity. I appreciate you watching, appreciate you taking the time, and we'll see you in class.